Okay, so I think we're live, so we'll make a start. So good morning, good afternoon, or good evening, wherever you are in the world. My name is Mark Foley, and I'm one half of the presenting team on this Safer Kubernetes with Open Policy Agent presentation today. Before I go any further, I'd like to introduce my colleague who's going to be doing the sharing the presentation duties with me. Shaman, do you want to introduce yourself?
Absolutely, Mark. So hi, everyone. My name is Shaman Kiani, and I'm the other half of the M&S team. And I'm an associate solution engineer here at VMware. So I started around 1.5 years ago. And when Mark came to me with this opportunity to present with him on Kubernetes or Safer Kubernetes, I literally jumped at it. So I'm very excited to get started. So let's go, Mark. Let's do it.
Excellent, thanks, Shaman. So look, before we get into it, just a note, if you want to ask any questions or make any comments as we go through, you can use the YouTube comments feature and we will see those questions, and I'll stop periodically, have a check, and at appropriate times we'll go in and give you a response to those questions. So just a little bit of background on this presentation. The idea for this presentation came when someone sent me a link to a really interesting website called Kubernetes Failure Stories. I've been down a little bit of a rat hole on this because it's links to a whole bunch of presentations, blog posts, and write-ups of the weird, wonderful, and interesting ways that people have found to blow up their Kubernetes environments. And what was really interesting to me was, there's certainly a lot of those issues are perhaps related to bugs or unexpected behavior in Kubernetes, but a lot of it is around just people just not quite knowing what the right thing to do is or understanding what best practices around Kubernetes. And really, that's not that surprising, right? It's pretty new technology, and for something so new, it's just amazing how many organizations are running really, really large-scale systems on it. So, with one of the things that I think is lacking in Kubernetes right now is just that knowledge, that I guess call it tribal knowledge of best practices or what the right thing to do is. Just because Kubernetes is able to do something, it doesn't necessarily mean that we should do it. An example from earlier in my career is I used to work as a developer, and the organization I worked at made a lot of use of technology called database triggers. And if you ever use triggers, they're very powerful, but they can have some unexpected side effects. And, we spent a lot of time, around 6 months, just dealing with a whole succession of trigger-related issues. And at the end of that, we decided, actually, even though you can do this, it's not necessarily a good idea for us. So we made the decision that we weren't going to use those, and it ultimately made our lives a lot simpler. So, that is an example of a policy. Where we make a decision about some best practice or some practice we want to apply in our environment, and we go about enforcing that. And what I want to do now is just turn over to Shaman for, I guess, a little more formal definition of what policy is and how it applies in a Kubernetes environment. Shaman, over to you.
Thanks, Mark. So Mark mentioned tribal knowledge, right? It constantly gets fed into the organization through different streams, of what you can and cannot do, and it's based on certain requirements as well. So this tribal information needs to be fed into an engine, and that's called policies. And policies are essential to the long-term success of organizations because they take this tribal information or requirements and essentially encode them into their systems. And a policy is essentially a group of attributes that define, allowed behavior patterns, capability parameters as well, and labels as well. They tell you how to comply with legal requirements and work within technical constraints as well. So moving forward, you avoid repeating a lot of mistakes that you would have made beforehand as well. And the way that I like to think about policies is essentially like guardrails. Think about it. You're driving down the road. You know where you want to go. You know what's a safe path. You know where your destination is. But you have these guardrails or these metal bars on the either side of you that essentially stop you from swerving off the road and going into unwanted terrain where you don't really know how you would drive, you don't know what the conditions could be like as well. So policies are similar to guardrails where they tell you what you can do within your environment and what barriers you don't want to cross because you don't know what you can expect as a result of this as well. And policies can essentially control anything related to your environment or to the resources in your environment. So these could be your pods, your containers, your networking networking, your clusters, essentially anything. They can manage them through and through. And there's two ways you can apply policies as well. So one's manually, and there are cases where you should manually apply policies as well. When it comes to design review, when you need to see what a knock-on effect of applying a policy would be as well, what result could come across of that as well, and where you want to have those cases few and far between, you do need to manually apply them. But there's also cases, and what we want to move towards as well as our environment starts to get larger, is applying those policies automatically. You want to make sure that you have automatic processes in your environment that essentially allow you to apply those policies in a very resilient, cohesive, and complete way as well. So that's where our environments are starting to move as we start to integrate that resiliency in our environment too. And there's different ways you can apply policies built into Kubernetes. There's a couple as well. So role-based access control, you have networking policies, you have pod security as well. And where these are very fit for purpose, they suit their needs as well, and they allow you to define policies. There's also other issues that are introduced as a knock-on as well to them. And if you want to, go away from this, if you want to extend what your policies can and cannot do, then the issues start to come across as well. That's when you need, those third-party agents. For example, if you want to apply or you want to define a certain repository that people can use within your Kubernetes environment, then within Kubernetes itself, with these policies, there's nothing that exists that allows you to do that completely. And then that's where, what I mentioned, third-party agents come in. They allow you to extend those capabilities further as well. So we have Open Policy Agent that we'll be talking about today. And then we also have Caverno as well, which is a policy agent that's being created and customized specifically for Kubernetes itself. Now, Mark, if you just move to the next slide, I'll talk a little bit further about Open Policy Agent itself. So Open Policy Agent came across because the founders wanted to talk to a lot of different organizations and really understand their pain points. What was pressing in their environments right now? What was causing issues for the developers, the operations teams as well? And what they heard a lot of the time was that they had multiple different systems, and each one of these systems had its own policy module or its own authorization system that was essentially built into it as well. And where it might have been a very good endpoint type solution and it fit its purpose in that point, as overarching or a whole ecosystem, when you consider it all, it started to look very fragile. It started to look very fragmented or dispersed. And as a result of this, you got a lot of questions started to creep up on you as well. So one, how do you enforce new policies from these subsystems? How do you roll out policy changes as well? And how do you test, new policies for correctness? How do you see that the policy that you've applied fits its need in time? So those are the questions that start to come. And what you start to see as a cross of this is that the control, the visibility that you want in your environment across the stack starts to become a little bit more difficult to manage, starts to become a little bit more difficult to control as well. And that's where you start to get out of luck as well. But in reference to this, that's when Open Policy Agent comes in and really shines. Open Policy Agent gives you that ability to essentially offload those processes to a dedicated engine so that your administrators, that your operations teams can have a little bit more control over the services that they need at runtime. And the way that I like to describe Open Policy Agent is essentially like this. Think about a domain-agnostic, general-purpose policy engine that allows you to decouple policy enforcement from policy decision-making in a very timeless and beautiful manner as well. And that's exactly why VMware extensively works with Open Policy Agent as well across a lot of our solutions when it comes to customizing and applying policies. Now, Mark, if you just go to the next slide quickly. So I've talked about it. I've explained what Open Policy Agent is, what policies are, but let's have a look at a flow. Let's have a look at how this would look like in its entirety. So what happens is that your service will receive any kind of request that it needs to make a decision, a policy decision based off as well. And that service needs an authorization or a policy decision-making engine. And so that service will essentially knock on to Open Policy Agent and present that request that it received itself in a JSON object format. So that could be a HTTP API request or a Kubernetes admission review request as well. So once OPA receives this request, and it needs to make a decision based on it as well, it will make its decision using policies written in Rego language and the data it has access to essentially as well. So Open Policy Agent will take those attributes against those policies and the data that Open Policy Agent has access to and essentially produce a result or a decision. This could be either to allow or deny the type of a request that's coming in, anything. And then once it has a decision, it will send it back to the service to then be enforced as well. And I want to enforce here that, that service could be anything across the board. You might have certain policy requests coming in where you need to, apply complex passwords across different services. So where those requests come in and where you need to enforce that as well is where you would have to manually go in and, for a Linux-based system, Windows-based system, any of those services, you would have to before go in and apply that policy. Now, what you can do is have that one dedicated engine that can roll out that, complex password essentially policy and enforce it across, enforce that decision across multiple of these services in a very automatic manner, which is essentially what we want to get to as well. So Open Policy Agent does that, and it allows you to decouple policy decision making from the enforcement process itself. And so rules no longer have to be, hard-coded inside the application itself. You have a very resilient manner in which you deal with it. So enough talking. Mark, let's dive into what the code could look like. What does it look like in its actual entirety?
Yeah, thanks, Shaman. So that's Shaman's given a great explanation of, I guess, the theory of Open Policy Agent and how it works generically. I now want to talk about just how it might work with Kubernetes. And effectively today, there's actually two ways of integrating Open Policy Agent with Kubernetes. One of them, the old way, which we're going to look at now, and the new way via something called Gatekeeper, which we'll look at in a moment. I just want to use the old way first because perhaps it's a little bit simpler to understand. So effectively what happens is we might have a pod that we want to deploy to our cluster. And there you see some YAML that defines all the attributes of that particular pod. What we're going to do is we are going to then apply that YAML file to our cluster, and Kubernetes is very kindly going to turn that into JSON, which is useful because Open Policy Agent works obviously with JSON. So we now have a JSON definition of the change or the configuration we want to apply to our cluster. And if you recall from the previous slide, the way that Open Policy Agent works is our service, in this case Kubernetes, is going to call out to OPA. And what's going to happen is that the way we plumb Kubernetes into OPA, we will take the JSON definition and we'll wrap it in some other metadata, just some information about the request. What will then happen is OPA has embedded in it a policy language called Rego. So it's up to us to write a policy in Rego that defines the rules we want to enforce. And I have a very simple policy here that I just want to quickly talk through. So we're not going to spend a lot of time looking at the Rego language. It's a fairly big topic and it's a presentation all of itself, but I just want to give you a little bit of a feel for it. So here we have a very simple Rego policy. So a Rego policy is captured as a file and is made up of one or more rules. So this policy is about as simple as it gets. It's just a single rule. And that rule is basically going to be evaluated. And if the rule returns true, that means we should deny this request. So effectively, Rego is asking, OPA is asking, should I deny this request or not? And as you can see there, what's going to happen is we are going to look for the existence of a particular piece of JSON. So you'll notice this expression here, the not input.request, etc., etc. So this actually allows us to navigate through our JSON document. So input.request.object is navigating through, I guess, the metadata that surrounds our actual JSON definition for our pod. And then we can actually get into the piece of JSON that we have here on the left of the screen. So you'll notice we're looking for metadata. So metadata there, and then metadata in the JSON definition. We're then looking at the labels, and then we're saying, is there a label called HR in this particular JSON definition? And in this case, there is not. So basically, we are going to return true to say you should deny this particular request because this object does not adhere to our labeling standards. The other thing that's going to happen is we're going to define a message, and you'll see later on that that message gets returned to the user who's entered the kubectl request. So it's very clear as to why this request has been denied. So that's very simple overview of what the old way of integrating Kubernetes and OPA looked like. Now, there's a few issues with that old technique. Number one is it required a lot of manual integration. You ended up with manually configuring a lot of admission controllers yourself, which is not overly difficult, but it can be a little bit painful and it can be difficult to test. The other thing too is that we had a tendency for those policies to get very, very complex. You know, the reality is, right, if you've got a labeling standard for your objects, you're probably going to have different standards for different objects, and you're probably not going to just enforce one label. So you can see here, even with this very simple example, to turn this into something real world, you're going to end up with some fairly complex policy files. And so to address these problems and a few more, what the people at OPA have done is they have introduced the Kubernetes extension called Gatekeeper, which provides much tighter integration between Kubernetes and OPA, and it also solves some of those issues of complexity of definition. But Shaman, do you just want to walk through some of the things that Gatekeeper provides for us?
Absolutely. So as Mark mentioned, OPA has an extension called Gatekeeper, and there's essentially two reasons why this was introduced. One, because we wanted to make it a little bit more tight-fitted towards Kubernetes. We wanted to make it so that it works better with Kubernetes and essentially its own framework. So to do this, it uses the OPA constraint framework to essentially describe and configure and enforce policies as well. And secondly, we wanted to provide a little bit more consistency across our entire stack. As Mark mentioned, it can get complex. Each policy might have its own layout, and that can also, integrate into bigger policies where you don't really have that consistency. And that's exactly what we wanted to integrate with Gatekeeper. We wanted to allow users to customize admission control via the configuration itself and not the code. So what we wanted to do was bring awareness of the cluster state. So not only are we dealing with a single object at the time, but essentially the entire state of what we're looking at when we're looking at evaluating it. So Gatekeeper allows for further governance and security within your entire Kubernetes environment. And when you look at the flow, so the architecture that you have on screen right now, it's very consistent with what we had with the previous, where we just had Open Policy Agent. The difference now is that the API server will talk to Gatekeeper, which is essentially a customizable admission webhook, and that uses Open Policy Agent to then evaluate the policies written in Rego. And what other difference you'll see as well is that the policies where we just had, defined before are now considered as constraints with Gatekeeper. And a constraint is a declaration that, similar to policies, the author wants a system to meet a set of, given requirements. We want to make sure that we have these vetted against. But the difference now is that, those constraints have to piggyback or essentially rely on a constraint template. And you can't define a constraint unless you have a constraint template defined with it as well beforehand. Because that constraint template, so each template itself describes both the Rego logic that needs to be enforced, and the constraint also describes the schema that needs to be enforced as well. So the schema of the custom resource definition, which essentially makes it possible for you to work with a lot of the resources in Kubernetes environment, and the parameters that can be passed into the constraint. So similar to arguments being passed into a function. So having that constraint template essentially brings in that consistency, so you know what logic to use, what parameters to pass through as well, what will be what arguments to pass through as well to make it allowed or denied. So instead of following different logics across all of the policies, you have a little bit more of a concise and cohesive way of doing that. So Mark, did you want to go through the code side of things so that we understand, what these complex words mean when it looks at the code in itself?
Yeah, thanks, Shaman. And look, I think an example is a good idea. I had to read this bit of the documentation a few times before I understood what was going on. So examples work well for me. So here on the screen, we have some code samples, and we're actually going to look at this in a live environment very shortly. But On the left, you see an example of a constraint template, and you'll notice there's two components to it. Down the bottom, we have our Rago, and this is a very similar rule to the one I showed you earlier. It's a little more flexible. And instead of just enforcing one label, it actually allows you to define an array of label names. Still a fairly simple rule. So just a fairly simple piece of Rago down the bottom. Up the top, we have metadata about that constraint template, and it just gives describes the actual constraint template. It gives it a name, some data about it, and most importantly as well, it also defines that this particular constraint template, for you to use it, it requires a parameter, and in this case, the parameter is an array of strings. So rather than hard coding in the Rago of the constraint template, the labels that we want to see, a user of this constraint template is just able to pass them in as a parameter. So what will happen is we will go into our cluster and we can create a constraint template. By itself, that does nothing, right? So there's no policy applied, there's nothing to enforce. It's just a template waiting to be used. When we want to apply a constraint based on that constraint template, we need to create a constraint. And on the right of the screen there, I have two examples of constraint. So both of them use this constraint template. And you can see that by the kind reference at the top of the constraint definition. So that refers to this particular constraint template. Down the bottom, you see the parameters we're passing in. So for the top constraint, we are saying we're just passing an array of one string in length that just says, I need a label of HR on this object. The other thing about the constraint is it defines the objects that this constraint applies to. So in this case, this constraint is only going to apply to namespaces. So a fairly short, tight definition that says, hey, take this piece of Rago and make sure that all my namespaces have the HR label applied to them. So, that we're able to use that constraint to leverage the logic in the constraint template. And then I can use that constraint template again and again and again if I like. So down the bottom there, we have another example. In this case, some different objects. So we want to apply this constraint to a couple of different objects, in this case, pods and ingresses. And when we apply the constraint to the pods and the ingresses, we're using two labels. So for all my pods and ingresses, I need to see a business unit and an owner label applied to it. So hopefully you can kind of see that just by having a single constraint template, we can create a number of different constraints that are going to allow us to have a comprehensive labeling scheme in place without having to write a lot of complex Rago policy language. So that at a high level is how Gatekeeper works with constraints and constraint templates. So what we want to do now is look at a basic demonstration of how we go and apply this stuff. So what I have is a Kubernetes cluster, and let's just have a look at that cluster here. And the first thing I just want to point out is, as I said earlier, Gatekeeper is fully integrated into Kubernetes. So I can just go get constraints, and that is going to give me a list of the constraints, the Gatekeeper constraints that are applied in this cluster. So constraints and constraint templates are defined as custom resource definitions. We can manipulate them with kubectl as we manipulate any other Kubernetes objects. However, what I'm going to do for this presentation, it sort of helps make things a bit clearer and understand what's going on. But we are going to use Tanzu Mission Control, VMware product, to apply and manipulate these constraints. So let me bring up the Tanzu Mission Control user interface. And while I do that, Shaman, do you want to just explain why we're using Tanzu Mission Control in this example here? Oops.
Absolutely, Mark. So, nowadays our organizations have a lot of development teams, and each one of those teams could be managing or running applications of Kubernetes. And because of this, there could be multiple Kubernetes clusters that start to spawn as well. These clusters could be spread out across, multiple cloud endpoints or multiple locations as well, because they need to deploy their own applications, or they need to deal with their own, little segments of or different streams of pipeline or development that they're working on. So it starts to get a little bit more complex, right? Your environment starts to get a little bit more wider, and it starts to get harder to manage as well, especially when you think that each one of these clusters could be treated as its own security domain. So once again, how do you spread out and how do you apply policies to each one of those clusters? How do you consider security? How do you consider roles? How do you consider the networking piece? So each one of these little clusters and the considerations that come with it start to get a little bit more heavy lifted for the administrators or the operations team as well. So this is where Tanzu Mission Controls comes in and saves the day. And not only does it have a really nice interface to deal with, but it provides you with a way to apply policies to your clusters in a very consistent, cohesive, and complete way. Tanzu Mission Control is VMware's own solution to provide you with the management platform for consistently operating and securing your Kubernetes infrastructure. And one of the main benefits that I love to point out is that you're able to apply these policies once and push them across multiple clusters at a time. So that automatic process or that automatic route that we want to take starts to come into that whole picture. And so you would have a cluster group that you define, which a bunch of resources within that as well, as Mark would have created. And then within that, I've created these custom policies. Now, this one's called NS Purpose. And the beauty of Tanzu Mission Control is that you can logically define what kind of resource you want to apply this to. Namespace is mentioned here, but you can do that across any of the other resources. So you have pods, you have events, config maps, you name it, you can mention it here. And then you also define parameters, so labels that you want to configure it with. And so what we've done here is we've defined it with a purpose label. So we want to make sure that across that entire cluster group, we have each namespace needs to be defined with that specific purpose to know what is happening, why are we including this namespace in there, and what can we categorize it with it as well. And so what Mark will show you now is what that will look like in reference or in code. Thanks, Mark.
Excellent, thanks, Shaman. And just to be clear, so all the examples here and all the Gatekeeper capability, you don't have to be using Tanzu Mission Control to access that. Say Gatekeeper is an open source project, you can download it today and use it right now. It's just Tanzu Mission Control makes it a little bit easier to use. And as Shaman was saying, when you're running environments at scale, it becomes very, very handy. So, as you've seen there, you sort of can see the policy that Shaman applied, and that policy basically translates to all our namespaces need a purpose label, because we want to understand what a namespace has been created for. So let's have a look at our cluster and just see what namespaces are there right now. And you'll notice we have a bunch of system namespaces. We have the namespaces that the various Tanzu Mission Control and Gatekeeper functionality has been deployed into. And we also have our sample namespace there, which is one I created earlier. Now, what I want to do is create a new namespace called test. So let's have a look and see what that looks like when we try and create it. Just bearing in mind that we now have this policy sitting there in the background that says, hey, every namespace needs that purpose label assigned to it. So, what happens? It's a little bit early in the morning for me. Sorry, everyone. Okay, so there we go. So we have our namespace test. I've tried to create it, and I get that error message coming out of my Rego. So that comes directly out of the Rego that I've defined in my constraint template. And it's a very clear message to the user that this is why this particular request has been denied. So if I actually want to create that namespace, I need to make sure that that purpose label is associated with it. So I've put together some YAML a little bit earlier, which is this little file here, and you'll notice that I've defined that purpose label. So what will happen is when I go and apply that YAML file, then the namespace gets created. I can see there that our namespace is now there. We have our test namespace. So, and that allowed me to create it because it's compliant with policy. So that's the application of policy to a brand new object. What about the objects that are already there? So you can see that I have that namespace sample that already existed before I went and applied that policy. Let's just have a look at that namespace and see what labels are associated with it. You can see there it's got a label test, but it doesn't have the purpose label. So what if I try and make a change to that object, given that it's not currently compliant with our policy? Well, let's go and do that. So I'm going to try and apply another label to my namespace, and again, it's not the purpose label. So when I go and apply this, again, right, the policy is still applicable, even though the object was created beforehand. And the only way I'm going to be able to make changes to that particular object is to get it compliant with policy. So if I now try and add the purpose label, and that will be applied, and now I can do whatever I want to. I can now continue to make changes to that particular object. So what you'll see there is that the policy gets applied to all of the objects sitting in our cluster. So that's all well and good and interesting. We talked a lot about enforcement of policy, but what if you don't want to enforce policy? What if you just, as an administrator of an environment or a group of environment, you just want to be alerted when people are violating policy? Like I said, it's pretty unfriendly to just put a nasty error message there, particularly when you're initially introducing policy. So one of the things you're able to do with Open Policy Agent is you are able to specify whether to disable policy enforcement. So what that does is it means that even if someone makes a request that violates policy, the request will go through. However, Open Policy Agent has an audit function. So what you'll notice here is I have this other constraint that I've defined down here, and it's basically set up to require another label on our namespaces. In this case, we need the business unit label in our namespaces, but in this case, we've disabled policy enforcement. So what Open Policy Agent is going to do is it's going to apply its audit functionality to this particular constraint. And we can see that in Tanzu Mission Control when we go to the insights area, and you'll notice that these are insights into our policies. And for our custom policies, which are Gatekeeper policies, we have 4 issues. And what has happened is that Open Policy Agent, it's aware of these 2 policies we have. One is enforced, one is not. Because we applied the policy to an existing environment, it didn't retrospectively go and delete stuff. What it has done, though, is it's flagged policy violations against those 2 policies. So this XX audit only policy, that's one that's not enforced. So we're only ever going to see these audit insights. We're not going to have changes disallowed because of that policy. So you can see the cluster and the namespace that that particular violation applies to. And then here we can also see this namespace purpose. So that's the policy that's been enforced. And because that got applied to a cluster that has some existing namespaces on it that violate a policy, we notice that the default namespace is also in violation of policy. So as I say, you can use Open Policy Agent in a couple of different ways. You can have it enforce policy or just audit policy for you. The other thing that's interesting about this is that, when I showed you that cluster earlier, you would have seen there's a whole bunch of other namespaces in there. A lot of those are system namespaces or namespaces required for mission control or Gatekeeper. Why are those not appearing in here? Because I know for a fact that none of those namespaces have the required labels on them. There's a couple of things that you can potentially do to rule objects in and out of scope of policy enforcements. You'll notice when we have our custom constraints here, let's go and log in. So one of the things we're able to do, as well as specifying the objects and the parameters for the constraint, we can also say, hey, exclude these namespaces from compliance. And what that will do is exclude the namespaces and all the objects in it from the application of this policy. And the way that is done is by labels. So we could put a label on a namespace that says exclude from policy, and automatically everything under there will be excluded as long as we configured the constraint properly. Now, that's not what is happening in this case because we haven't specified any of these label selectors and there are no labels on those system namespaces. There's another mechanism that Gatekeeper provides us for excluding particular namespaces from the application of policy. And I'm just going to go into Octane here, which is a nice little free tool for visualizing our cluster. And I'm going to have a look at the custom resources on this particular cluster. And I want to have a look at the YAML for that constraint definition. So here we have the various required labels constraints, and just going to open up one of them and just put the YAML definition. So there's a lot of stuff there that gets added on by Kubernetes and Mission Control. But if I scroll down, one of the constructs we can see there is we're able to say exclude these particular namespaces from application of policy. And this list of namespaces, this is something that's automatically done for us by Tanzu Mission Control. So it has a list of all of the namespaces that you typically don't want to apply policy to. It'll automatically populate that and automatically exclude those namespaces from us. So effectively, when you use Mission Control, it means that we're only focusing on those namespaces that we typically want to apply policy to. So that's our basic demo, just to do a quick run through of Gatekeeper policy and how it works with Tanzu Mission Control. I think what we want to do now is just have a look at something, I guess, a little more real world. Label policy is all very nice, but it's not really going to help us in a big way. So one of the stories on the Kubernetes failure stories websites is a link to this particular post, and it describes an organization whose development cluster was basically cryptojacked. So some hackers managed to get onto that cluster and deploy some Bitcoin mining code on that cluster. Now, there's all sorts of reasons why this is not that desirable. The thought of people being able to deploy random pieces of code on their cluster is not great. And obviously, if you're running a cloud environment, this has got something that's got the potential to get very expensive if it's not discovered quickly. So, this is an example of a sort of thing where we might be able to provide some level of protection via policy, and not just to cryptojacking, but also to, prevent anyone from being able to execute their own code on our cluster. So I want to talk about some example policies we might put in place to protect against this sort of thing. And look, this example is a bit more real world, but it's certainly not a comprehensive set of policies that you might use. And I'll talk about what they might look like a little bit later on. In this case, we have a few different policies that we want to apply, and they fall into a couple of different categories. One is around making sure that the code that's running on our clusters is trusted code only. And by that, I mean, we know what the code is. We know exactly what version of code is running on our cluster, and we know where it came from. So basically, it came from a trusted repository, and people aren't just allowed to log into our clusters and go and deploy code from any random image repository that they have access to. The second thing we want to do is, and this is a fairly common use of policy, is provide the most restrictive set of permissions and privileges to the pods as possible. So in this case, I'm just going to do provide one restriction, which prevent a pod from running in privilege mode. If you're not familiar with what privilege mode is, effectively, if you run a pod in privilege mode, what it's going to allow that pod to do is get access to the resources of a host. So basically allow it access to the networking stack, devices, storage, things like that, which generally is not a great idea. So that's not something we want to see happening. So Shaman, you've set up these policies. Do you want to just quickly walk us through how you set those up? And we'll use Mission Control again to walk through those.
Absolutely. So we have the disallowed tags one that Mark briefly mentioned as well. So what this does is it basically allows each resource, pod resource, to have a tag named latest against it. So what it does is that, as Mark mentioned, you don't want to have the latest tag defined for each pod because you don't know what what specific tag or version or build or tag, you know, that specific pod might have. All the information you have is latest or the image ID itself. So if you want to roll back, or if you want to know what is included with that image as well, it starts to get a little bit more harder, and that is a security concern you could deal with. Apart from that as well, you would also have the only allowed GCR, a custom policy that I've created as well, which essentially makes sure that each pod is only allowed to reference the GCR.io policy image repository. And this is Google's own repository. This is what I mentioned at the start of the presentation as well. You want to specify, you know, certain policies and certain repositories that users are able to reference from, because there's no point in securing your internal network if you're able to introduce a leak or an issue from an external source inside of your environment. And the last one here is just basically exactly what Mark mentioned, where you would essentially ensure that no pod, so to essentially any type of pod, is able to reference, you know, or apply the privileged access for each pod, because you don't want to give anyone privileged access unless they have a compelling reason for, or they need it, because they can get into a lot of sort of trouble as a result of that as well. And so what Mark will show you now is how you can enforce those policies through, and how it's basically looks like in code as well.
Excellent, thanks, Shaman. And sorry for getting a little bit distracted there. I realised I've left the environment for my demo not as clean as I thought it might be. So a few things were going to fail. So hopefully I've sorted that out now. Okay, so as Shaman was saying, we now have a set of policies that are deployed on this particular cluster and all the other clusters in that cluster group, and they're going to hopefully stop some of these undesirable events from happening. So let's have a look at a couple of YAML files that I've prepared. So we first of all have this one, which is imaginatively named bad, and this is basically something that's going to fail, right? And you can see what we have there is the image definition, so this Hello app, which is a Google sample app. Firstly, I haven't declared the container repository where this comes from. So this, depending on how a cluster is set up, generally what will happen is it will try and download that from a Docker repository. Not something I want to do. I don't necessarily trust all the things that are in the Docker repository, so that's why we've specified the Google Container Repository. And again, in the real world, we'd probably specify some private repository as a trusted repository. Again, you'll notice there's no tag on that image. So by default, that's just going to go and get the latest version of that particular image. So as we talked about, not desirable behavior. And the last thing there is that this particular pod is asking for privileged access. So fairly predictably, when we go and try and deploy this, what's going to happen is it'll fail, and all the policies that have been violated, we will get a message that a message from them that was specified in the rego. So it's very clear to the user why that particular deployment has failed. So they're going to see that list of issues, and then what they're going to be able to do is go into the YAML and correct it. So here's an example of a good deployment, right? So you'll notice I've fixed up all those issues. I no longer am asking for privileged access. I have specified the specific image repository I want to use. I've specified a label, and if I go and try and deploy this one, that should work just fine. So let's have a look at that, see what happens. And no problem at all. And if I just get pods, you'll see there that should have deployed nicely and is running well. So that's a nice, simple example of policy applied to pods. I want to just talk to something, one, a little bit more complex, and also just address a question that sometimes people raise with me around performance. Does policy impact performance? And look, usually the answer to that is no, right? So generally, policy will be applied in response to configuration events. So changes, deploying new pods, deploying new objects to our cluster. That is not usually in the application response path. So it's not going to interfere with your application code or your response time. There's one example where you have a very, very faint possibility of impacting performance. And this kind of arises on just around the way that Kubernetes works and how it interacts with those policies. And it's probably a good idea to illustrate this with an example. So what I want to do is talk about a higher level Kubernetes construct, right? So we have a deployment here, and that deployment references a pod that we want to deploy as part of that deployment. And that pod is again going to be the Hello app. But again, you'll notice that this seems to violate some of those policies that we've configured. So firstly, no container repository specified, no label specified. It's not asking for privilege, but this should be something that fails. So Shaman, question without notice, when I try and deploy this deployment, what do you think is going to happen?
I think Mark is going to fail, but let's see.
Yeah. And look, you're right and you're wrong, I guess, is the answer there. It will fail, but it might not look like it failed. So let's go in there and try and deploy that. So oops. It is only 9:30, I think, here, and I have a coffee. So
you're forgiven, Mark. You're forgiven. Don't worry.
Yeah, thank you. I definitely need a bit of a coffee in the morning. Okay, so as I said, that looked like that succeeded, and why is that? Well, it kind of gets into the internals of Kubernetes. So effectively, we have an object of type deployment, and what will happen if you cast your mind back to what deployments actually are, is internally the deployment gets created, and then the deployment will create a replica set, and then that replica set is going to go and create the pod. So we are not doing that ourselves. When we create the deployment is interacting with the Kubernetes API to go and do those things for us. So while it looks like this particular deployment has succeeded, if we go and look at what's happening in there and see the status of our deployment, you'll notice, firstly, it's not ready. If I go and have a look at my pods, well, we only have the hello pod that we deployed earlier. If that deployment had been successful, we should at least see another pod in there, at least trying to start up. So let's look at what's gone on with that deployment. And you'll notice when we have a closer look at the deployment that not a hugely intelligible error message, just that the replica set failed to create a pod. Now, for a user to understand what's going on, what they're probably going to have to do is go and have a look at the Kubernetes event log, and this is where things become clear. So you'll notice the last two events to occur are the failed create of the pod. Right, so what's happened is the deployment gets created, that's fine, but when it goes and tries to create the replica set, which tries to create the pod, that fails, and we see those messages in the event log. So, all pretty logical when you think about it. How could you make that more friendly to a user? Some of the things you can do, you'll notice that when we create our constraints, we are able to specify things like you can apply the constraint to not just a pod, but a pod template. So what's a pod template? Well, the pod template is that bit of a deployment that defines what our pod looks like. So effectively, this piece here. So if I applied that constraint to our pod and our pod template, then the user would get a really nice message, right? So, you can do that, bit of work, but it's just something to bear in mind. And this kind of brings us to that question of performance that I talked about. As I said earlier, generally policy, when we apply policy, it is not going to impact our application code. Our application code, once we made our configuration changes, our application code is just going to keep working, and we generally don't expect to see configuration changes or policy changes as our app's running in normal circumstances until we try and make a change. The exception to that is if you turn on pod autoscaling. So if I turn on pod autoscaling and I need to autoscale, increase the size of a replica set, increase the number of pods or decrease the number of pods, that'll happen automatically in response to application load, and policy gets applied then. So if you've got a policy that takes a long time to evaluate, then in theory, this is where Gatekeeper could potentially impact your performance. Practice, not really likely, right? That policy evaluation is really quick. In general, it'll happen much faster than it takes to actually create a pod and get that initialized. So as a general rule of thumb, you typically don't have to worry about performance, but there's that one, maybe there's a couple of other edge cases I've missed where potentially it can get into the flow of the application. So look, that ends the part of the presentation where we're just going through the demonstrations. I just wanted to talk a little more about some more real-world policies that you might put in place, particularly around security and particularly around that cryptojacking example that we've been talking about. The things you might add to that to really lock down your environment. You might require network policies for your pods. So people need to explicitly specify what your pod can and can't communicate with. A lot of people require that limits are specified on pods to restrict the amount of resources that a pod's able to claim. Specifying a security context is always a good idea. So, if you don't put that security context information and information about the identities of a user and the groups that your pods run as, then that can have some unexpected side effects. In general, if you don't specify security context, your pod will assume the identity of the container. And if that's at a higher level than you expect, that can potentially cause problems down the line. So look, there's a whole raft of different policies you can apply. And in a minute, we'll talk about some places where you can go and see some example policies. So look, Sharman, I'm just going to hand over to you to basically summarize what we talked about today.
Yeah, absolutely. So we've mentioned that, where there's manual processes that you apply in your environment, you want to move towards a more automatic process. And that's exactly where, Open Policy Agent and with Gatekeeper comes in. So Open Policy Agent's a very powerful platform agnostic policy enforcement solution that works across the board with multiple types of services out there as well. It allows you to push those policies and make that decision-making process much more resilient, much more possible, and much more easier as well for your entire workflow. And then as an extension of OPA, we have Gatekeeper, which allows you to work, a bit more better. It's strongly integrated with the Kubernetes environment, so it allows you to have that hold. And where the policy's definition in Open OPA could be a bit more complex and spread out in its logic, Gatekeeper takes that logic in and basically allows you to have a little bit more of a consistent flow with how you define it, in terms of its configuration itself. And then a way to do this at scale with your different security domains, with those clusters all spread out throughout your environment, is through Tanzu Mission Control, a very seamless way to, take a policy and apply to multiple clusters at once. And it does it as we showed you in a very seamless way as well. So it's a very good tool to start considering in your Kubernetes environment. And Mark's also mentioned some resources as well that you can go to. Mark, did you just want to speak to them as well, just to get people, who are interested in this started off?
Yeah, thanks, Shaman. Look, and that's a really good segue. So we've had a couple of questions come in around policy libraries, and also there's a question there on a library for conforming to industry standards. So the example there is CIS. So look, I'm not aware of a Rego library of a Gatekeeper library for conforming to a specific standard. However, there is a Gatekeeper library. So the Gatekeeper project is on GitHub, and a sub-project is the Gatekeeper library. So there's a bunch of policies there that people have defined that you can take and use, or use as a starting point for your own set of policies that you want to apply to your own environment. As I mentioned earlier, though, one of the nice things about the Open Policy Agent is it is intended to be cross-platform. So it's built in such a way that it can be applied to lots of different systems. So what you might want to do if you're interested in compliance in a specific to a specific standard, what you may find is there are policy libraries written in OPA or other environments, so databases, operating systems, web servers, that type of thing. So there's actually a fair bit out there that probably provides you with a good starting point for how you might want to encapsulate a particular standard as a policy library. So as I say, there's some pretty good resources out there around Gatekeeper as well. If you're interested in mission control, you can actually have a look at that and run a hands-on lab, and there's free trials of that available. If you haven't seen Octant, I would encourage you to have a look at that. That's a free utility that's quite nice for just navigating and understanding what's going on in your cluster. If you're fairly new to Kubernetes, it's a good way to understand it too. The other thing, which I just realized I forgot to put on there, is the Open Policy Agent website. So if you're interested in learning Rego and just how to write Rego code to develop your own policy, that website's a really good resource. It has a Rego evaluator on there, so you're actually able to, they have a whole lot of sample code, but you can modify, see how that impacts your decisions. It's a really good learning tool that I use to develop some of these pieces of policy that you see here today. So look, I think we are a couple of minutes early, but we're pretty much right on time. So I don't think there's any more questions. Let me just check that. No, we're all good. So no further questions. So look, I would like to thank everyone for your time today. We really enjoyed putting this presentation together. So I think with that, Shaman, do you want to say goodbye, and then we will close out the session?
Absolutely. Thank you so much, everyone, for listening. And thank you so much, Mark. Really love the opportunity and really love this as well. Till next time, let's do it.
Excellent. Thank you very much. And cheers, everyone. Have a great day wherever you are.
Bye, guys.